Okay, so given this function, this is an exponential function, so we should be able to answer pretty much anything about this graph. Now, again, on the final, we're letting you use a calculator on the whole thing, so I guess you could even use your calculator, but I'm going to go over it as if I had no calculator because that's how we taught it to you. But 3 to the x is going to look like all exponential growth. All exponential growth goes through 0, 1 and has that shape of the graph. And then looking at the transformations, if I had plugged the number in for x, the first thing I would do is subtract 1, which is going to shift my graph right 1. So it's going to look roughly like this. And then finally, I would subtract 2 at the end, and that transformation would shift the graph all down 2. Now again, on the final, even if you think you know what it looks like, you should probably double check with your calculator. Again, don't spend too much time on your calculator, otherwise you won't finish. But for me, this is enough to figure out a lot of these questions already. The domain, it goes forever to the left, and it goes slowly to the right, but it does still keep going to the right. There's nothing stopping you from the x values getting bigger. So the domain is all real numbers. Range, this is where I like to have the previous steps in front of me. The range was 0 to infinity. You shift it right 1, it's still 0 to infinity, but if you shift it down 2, now it's -2 to infinity. We're describing the y values that the graph hits. And it never hits -2, it just approaches -2. That's why we need a bracket there. Okay, the horizontal asymptote is that number that it's trying to approach. So it's trying to approach y equals -2. Y equals because it's horizontal. From left to right, like you read a textbook, the graph's going up. So we say that it is increasing. My little sketch here is not near accurate enough to know the y value when x is 3, but I could just plug that in algebraically. And you get 3 squared minus 2, which would be 7. So 3, 7. Y-intercept's the same idea, except you have to know that for a y-intercept, the x value is 0. So plug in 0 for x. You get 3 to the -1, which is like 1/3 from exponent rules. And 1/3 minus 2 would be -5/3. Now, even though my graph's not super accurate here, and I wasn't trying to make it super accurate, I still have some idea if these numbers make sense. 3, 7, somewhere up here, looks close enough. 0, -5/3, that looks pretty close to my graph. But of course, if I plug that in, solved it algebraically, and it did not match up with my sketch of the graph, then that would be a red flag that something's off. Okay, and then to come up with that graph, we first need to move in the direction of right 1 units because of the x minus 1. And then the -2 at the end made it move down 2 units. So I didn't ask that till the end, but I really needed it to get the graph to start off. Okay. Is that enough for 11? Okay. Anybody else that was wanting to ask about 11 need to ask anything more detailed? Again, you should practice this without a calculator because this is how we taught it. When you guys use this in calculus or when you do this in college algebra, you know, there's a good chance they're going to expect you to know it without a calculator. So it's good to practice it. But on the final exam, you'll get a calculator, so you've got that as an extra little check, a little bit of a backup plan on this type of question.